Okay, so the very first thing we're going to do is the trend analysis. And you can analyze your trend with two different things, or at least that I know of. First one is called the exponential weighted average. And that one, maybe if you are familiar, it basically is like a moving average, but but the last period is weighs more. That's put more weight on it, so it's a little more accurate. And we're using this to determine a trend. And we can see if the stock is, for example, an upward trend or downward trend. And for investors that are trading on a long-term basis, they mainly look at longer periods of time, like a 50-day and a 200-day moving average. And if you're a short-term investor, you might look at shorter time periods to calculate a exponential weighted average. And that is because the shorter the time period you're going to use, the more sensitive it is to price changes. And the longer the period, the more it doesn't recognize noise in the stock prices. And yeah, so another thing, actually, we're going to look at this after. I would suggest now let's go to our Jupyter or Google Colab. And again, make sure that you load all the lines of code before. So I've already loaded them and we are starting from here. So another thing we didn't do last time is when we renamed our column, the adjusted close, we only did it for Tesla. So we also have to do the same thing for Apple. So that's the very first thing we're going to do right now. So again, we can rename the Apple data set where we stored our variable. And we are only interested in the adjusted close. Let me just check the chat. You see there's okay. So I hope everyone's good. So again, we are only interested in the adjusted close price. And make sure you put double square brackets. And then we are going to rename the column to adjusted close, but this time make like a little dash underneath. So just to connect the two words, which is much better. And in place is equal to true. Again, like last time I mentioned, just means that we are not creating a separate variable. We're just storing that new name in the old variable here. And after, we can take a look at the head of the Apple data set or data frame. And it should give you this. It should just give you the first 5 rows. And the adjusted close should be renamed with an underscore. Okay, so now let's get to the trend analysis. And as I mentioned to you before, this is just to see if a stock behaves on an upward trend or downward trend. And we will define a function, so don't worry about it. This is a very easy function. It shouldn't like scare you. So again, when you define a function, the first thing you have to do is write def, and that means we are defining a function. And then this here, trend analysis, is simply the name of the function. Nothing else. You can name this any way you want. And we are going to use an argument here, df. And df means we can pass any data frame into that function. And if you are familiar with functions, you know we have to like make 2 dots here. And then we write here what we are going to do now. So first we want to create a new column in the data frame that we call weighted moving average. And this is how you create a new column. You just write df, and we use df because we can pass any data frame into that function. If you will call this, you could also call it apple, for example here, but then you can only use apple here because it wouldn't make sense. Okay, the next thing is we are interested, we want to get the moving average from the adjusted close price.
Yeah, I hate to interrupt, but
Sorry, yeah.
there's an error going on in the date time.
What?
Uh, yeah, for the part where from the early workshop,
Mm-hmm.
yeah, there's an error which says name date time is not defined.
Oh, okay. So did you import the date time module in the
Oh yeah,
beginning?
wait,
You
never
did?
mind.
You got it?
I should. Right, because I need to run everything in order to
Yes,
get
you
something
have
to
to
work.
run. You
Ah,
have to run all the lines before
oh
to make
yeah, no
sure you're,
wonder.
yeah,
Literally, because everything's so sensitive here. All
yeah.
right, yeah. Otherwise, everything's good right now.
Cool. Can we move on or should we wait
Yeah,
for?
please. Let's move on. I'm
Okay.
sorry.
Yeah, no worries. Okay, so we are creating a new, again, new data frame, new column in that data frame. And we want to calculate the moving average or the weighted moving average for the adjusted close price. And that's why we named it before. Each data set that we created, the Apple and the Tesla, had the same, we named it exactly the same so that we can use this more general approach. And we are basically accessing this column and we're using this EWN, which is like, it's like a function which calculates the exponential moving average for this stock, for a stock that we pass here in this function. And the span here is a parameter, is the number of days that we are going to use. And again, as I mentioned to you, there's no right or wrong way in how many days you calculate it for. But if you trade stocks, like more as a short-term trader, you might be more interested in a shorter time span. So we're just gonna use 3 days and adjust is equal to false. That's just another parameter. And then we have to also calculate the average. Mean stands for average. So you just add it on to at the end. And another way to calculate an average is the moving average. And that's not, it's a bit different from the weighted moving average because it just calculates the average of the time period we passed here. It doesn't give more weight to the latest stock price. It just simply calculates the average for the last 3 stock prices. And again, we create another column on that same data frame. And we also want to access this adjusted close because that's the column we're going to use to calculate it. And this time we say rolling, and that's just also a function that calculates that moving average. And window is like span. It just determines how many days. And mean is again, the average. And after you created that function, you have to always say return df, and that's just, we just want to have the data frame. We just want to see it after we apply the function. Okay, so next thing we have to do is we have to actually apply the function. So once you do this, nothing happens except that we created a function. Next, we actually have to write this part here, trend analysis, and we can pass the data frame in here that we first updated. So we're going to use this data frame, this short one, and pass it into our function. And we have to do this for Tesla and for Apple. And once we load it, it applies the function to the data frame. So you probably don't see daily returns because that one comes after. You will only see weighted moving average and moving average at this time. Okay. So this is basically how you can make two easy calculations. And we will plot this in our last workshop. It's just because we would just want to create the variables first, and then we will plot everything. Okay. Another function I wanted to show you is the describe. I could have showed you last time, but I forgot. So this gives you like the minimum, maximum price, for example, of the adjusted close within that time period. It's nice to just take a look at it. It gives you kind of an idea in what price range we are with the stocks and how much they grew within a year. Like you can see that the minimum price in 2019 was $35, and then it went all the way up in 1 year to 2020 to $86. And the same you can see for the moving average and weighted moving average and average. Okay, so that's the first thing I wanted to show you. And the second thing we're going over today is the risk analysis. And we are actually using the standard deviation for that. And just a refresher, standard deviation measures basically the dispersion from its expected value. And a high standard deviation, if a stock has a high standard deviation, it means it experiences a higher volatility and signals a higher level of risk. On the other side, a low standard deviation means there's a lower volatility, and that also usually means lower risk. And we can answer with this question, or with the standard deviation, a really good question for someone who's maybe a risk averse person. Like if they're interested in which stock is like less risky in terms of the standard deviation. And we can analyze that using Python. So another thing to mention is that the standard deviation is also just one measure. There's different ones you can use for stocks. One that I don't go over today, but is definitely worth looking into is the beta value of a stock. And if you're interested, I created actually a tutorial on that as well. So if you can check my GitHub, yeah, if you want to learn more. This is a little more advanced. But if you took Finance 3000, you should have covered this in the class. Okay, so back to standard deviation. Now let's do that on our Google Colab. Let me just see if there's any questions. Okay. Okay, good. Okay, so how risky is it to hold stock A compared to stock B? Very easy way is just calculate the standard deviation using this very simple function. But it's hard to really say what's like a good range, like what's a low standard deviation high. So I think the best way is to just compare two different stocks. And then you can get a better answer for your client, for example. Okay, so if I run this, and just to remind you, we're using Tesla _ dot adjusted close and then .stv. And we are just basically calculating the standard deviation of the adjusted close price. And it gives me 10.6. So I don't really know if that's good or bad, but I will compare it to the Apple stock. And we can do this also by creating a function. And this time, we are passing the function 2 parameters. So we have 2 data sets and we want to compare which one is riskier. So in this case, we have to, again, we give it a name. We just say it's risk analysis. And we are going to create a variable, which is only accessible within that function. Okay, we just need this to create that if statement. So we have to create it first. And we're gonna just call this std underscore symbol A. And it doesn't matter if you use this for Apple or Tesla, but you have to make sure when you pass the data frames here that you do it in the right order. Otherwise, you're getting the wrong numbers. Okay, so we are basically now accessing the data frame 1, which I will be using as my Tesla. And then adjusted close .std will calculate the standard deviation of the Tesla stock. And we have to do the same for Apple. And this time we just call this std underscore symbol B. And we will be accessing the data frame 2. And I will show you later how this will look like when we apply the function. So data frame 2, we also calculate the standard deviation. And once we did that, we can create an if statement within that function. So the if statement will tell me, like, if the standard deviation of stock A, which in my case is Tesla, is greater than standard deviation of stock B, or symbol B, then print Tesla stock is riskier than Apple stock. And that here, I just remember because symbol A, I use for Tesla, so I just say Tesla is riskier. And if the standard deviation of symbol A is smaller than the standard deviation of symbol B, then print the Apple stock is riskier than Tesla. And if you run this, and here now we're applying the function. And again, make sure you pass this in the correct order. So you say Tesla underscore, and then that's PF1. And for Apple, it's in the place of PF2. And when you run this, it should print you which stock is riskier. I hope everyone is good. And I hope I'm not going too fast. Just make sure. Okay, cool. Okay. Are there any questions?
I think we have to like make some lines of code for that. Was it the Apple section?
Where? Can you tell me
Maybe.
where you are?
Shoot. Let's see. On your GitHub, I'm at browse code part 2. Ah, okay. Wait. It's the one where we do the same thing for Tesla, but we only do it for Apple.
Okay. You mean up here?
Yeah.
Yeah, so what I didn't do last time, I didn't do the same transformation for the Apple data frame that I did for the Tesla. So I just basically did it here so that you can use it when you move forward.
Okay.
I'm sorry to cut this off, but then you see on the lesson 2, after the statistical analysis, you name Apple, right? Right there.
Where?
Can you go a little bit up?
Mm-hmm.
Yeah, here. You do the Apple underscore is equal
Mm-hmm.
to Apple. I mean, so here I think it's giving me an error. I don't know if it's giving an error for others, but it says
Wait, did you run everything else before that?
I think so.
Yeah, make sure you run
Okay.
everything before.
All right. All
Um,
right. All right. From the
okay.
beginning, you mean, right?
Yes, from the
Okay. All right.
beginning.
Okay. Thank you.
Okay, cool. So basically now we could answer this question, which stock would you recommend a risk-averse person? And we could answer this by saying, based on the risk and the standard deviation, the Apple stock is less risky, um, but it might not have like a high return as Tesla. So that's what we are gonna do now. We're gonna look at the return. And honestly with you, I would have plotted it because it's much easier to imagine it if you see the graph. But because we divided it into three, we'll do it next time. So sorry about that.
Cool.
Okay, so now the return analysis will tell us. Wait, okay, Christian has something in the chat. Do you need help or are you good? Oh, you might have to restart maybe the collab, Google collab.
Turning on and turning off.
Okay, so now we are gonna do a return analysis, and we can do this monthly returns and daily returns. And this should help us to monitor the magnitude of changes in the stock prices. So we just want to see from one day to the other if we had a positive return or negative return and how much that was. Um, so basically, how this is calculated is just a percent change. So it's pretty simple. You could calculate this with your hand, but it's much nicer to just do it with Python. And a positive value obviously means the stock has grown in value, and a negative value would signal that the stock has lost in value. Okay. And a lower positive and negative returns can signal less risk of holding the stock. So, for example, even if you have, let's say you have a Tesla stock and the returns are, I don't know, $200 a day or something, then basically it would be riskier because it could also go the other way. And that's usually the case because investors get paid for their risk. And that's why risky stocks are usually bringing a high return, but it could also mean that you lose much more than in a stock that doesn't have a huge daily return or monthly return. Cool. So let's go again and just check chat. Okay. So now let's go again back to the Google Colab. And again, just because I want you to work with functions, and it's actually much better if you use other stocks to have functions. We're gonna define a function for the daily returns. So you don't have to do it twice. You just have to do that once, and then you can pass any data frame into your function. So when we define it, we call it daily return analysis, and we are creating a new column on the data frame that we are passing into the function. And now we're just basically calculating the percent change. And that's it. So it's pretty simple. You basically, this is the percent change function, and it calculates automatically the percent change, and it does it daily because we are having daily data. So that's why it does it automatically daily. And then we say return df. And again, this doesn't do anything unless you apply the function. And that's what we're doing here. So we would say, we will call our function, and then we will pass it the data frame of Tesla, and also here, the data frame of Apple. And when you run this, you should see a data frame that looks like this. And it has a daily returns column. And now what it does is basically, you see there's a negative because it calculated the percent change from this one to this one. And the price went down. So, and if the price goes up, it calculates the percent change from this one to this price. And this will help us later when we plot our data to get a better understanding of what the returns are on a daily basis. And you can also do the same for monthly. So if you want to just see the monthly returns, that's usually also when you're more interested into trading long term. And that's what we're doing now. And for monthly returns, we are actually creating a new variable. And that's because if you would create it here on this data set, you wouldn't have any values all the way until 30 days after, because it takes the average of the last 30 days. So in order to do the monthly returns, we would take the close price, adjust the close, and now we have to say resample. And here we pass it an M, which stands for monthly, and forward fill, that's the second argument I have to put, and then the percent change. And I'm also putting a 1, so it starts actually after the first row. Actually, after the first month, yeah. Okay. So basically, you have to do this you have to do this twice, one time for Apple and one time for Tesla. And when we run this, and you now look at the monthly returns, you will see that it was reduced to 12 their values only because it's monthly, and we only look at 1 year. So we can see that in 2019, or after February, the return was 0.04, around 4%. And then you can see it from February to March, it was 0.09. And yeah, do you have any questions about this?
Oh yeah, I forgot the dot right here. Oh crap, I forgot my mic was on. My bad.
Oh, no, it's okay.
Actually, it is giving me an error on the trend from the trend analysis.
Okay, let me.
Which part of the code are you on? Wait, did you name the apple, pal? Ah, I knew I should have had something commented down here.
Does anyone need help from the beginning? We have a lot of time. So if anyone needs help to load any of their cells, just let us know.
Oh man, Funny thing is I misread the M as an N. No wonder how I got the error.
Cool. So, since we have so much time, I can quickly show you how the beta thing works if you're interested. I'm actually going to pull up the project I worked on. And it is definitely, you can try it on your own. You don't have to do it now, but it's interesting.
Huh. This would be helpful if I wanted to get a friend and suggest to a friend what stock they should invest in.
Yeah, it's a beginning. There's like so much more you can look at, but I feel like for the beginning, that's a good, just easy ways to look at it.
Okay.
Okay. So if you wanted to do an analysis on the beta value, let me actually just explain what it is.
Okay.
So it measures the amount of systematic risk relative to the whole stock market. And you can use the SP 500 as your other measure. So you basically compare the S&P 500 with a normal stock and see how risky it is. Let me show you better. It's easier to show you. So we will create graph like this next time. So yeah, be prepared.
Okay.
So what we do is basically we will plot the S&P 500 when you do a beta comparison, and you also plot the returns. So this is monthly returns. The
Okay.
orange one is the S&P 500. That's the returns of the whole S&P 500 together.
All
And
right.
the blue one is Tesla. So the returns of Tesla. So basically you can see that the Tesla stock has much greater
Their
returns.
return is strong, it seems.
What?
Their return seems strong. It's greater than the SP 500, right?
Yes, and it's also much lower in some cases, right? So you can see it's going much more above and below than the S&P 500. And when that happens, that means usually a stock behaves aggressively,
Mm-hmm.
and the beta value should be greater than 1. If you remember from finance, that's basically what you learn. So if it's greater than 1, it behaves aggressively and the returns are usually much higher, or it can also happen that they are much more below the market returns.
Yeah.
And we also I did that with Nike as a comparison. So Nike behaves a little less aggressive. Like it actually, so now we have Nike is the blue one, and S&P 500 again. It's
Wow,
not as great.
Wow,
I mean,
it's
it's,
taking major dips right there.
yeah, it does.
Ah,
But when I calculated the value, the beta value, it actually came out that Tesla has a greater beta value, which
wow.
was greater than 1. It was 1.31, and that would basically mean it's an aggressive stock. And on the other hand, the Nike stock, I also calculated that beta value, and it was below 1, and that usually means it's a defensive stock. So that's how you can compare also the risk. It's more risky to hold a stock that has a much higher beta value, but it can also bring you much greater returns.
Okay.
So yeah, if you're interested in that, you can look at that. It's pretty interesting. Cool. And another thing I didn't mention before is the trend analysis is basically telling you the upward or downward trend. I think I mentioned that, but how do you actually see that? You basically would just see if the weighted or the moving average is increasing over time, and that it would show that it's an upward trend.
Okay.
Yeah. that's
I
pretty
see.
much it that we're doing today. But I will stay on if anyone has questions.
Okay.
Yes, I have question.
Sure.
I have issues with the input. It's showing me error while I run it.
The first input or where
Yeah,
are
first
you
input
exactly?
at the beginning.
Wait, did
Okay.
you forget to import everything?
I put those input code, but it's showing me error. Says it's not found.
Let's see. So can you, it would probably be better if you can share your screen, but
Yeah.
let me see.
Do you want me
Is
to
it,
share? Screen?
yeah, could you share it? That would be great.
Yeah, share. No problem.
Oh, right. It's right on here. This is to compare Apple v Tesla.
Are you sharing your screen yet? Oh, yeah,
Yeah.
now I can see it. Okay. Okay, import panda.
Bizarre.
Okay, so input. Can you tell me where the error happened?
It says
I mean, the code looks fine, but if I can see the error, then I might be able to see where it happened.
can I show you the window that I ran on, so
Sure.
you can see that. Yeah. So let me. Okay.
Okay. All right.
Can you see it now?
Oh, okay. Yeah, it says here import error.
Yeah.
Do you see that?
Yeah, it's like pandas as PD.
Yeah. Did you
Yeah,
import
the
that?
panda is not. Yeah, I put that on it, but
Import pandas as PD. Okay, you did. Can you try it again maybe after? Like, I see you already imported.
run it
so-
again.
Yeah.
Yeah, I can run it again.
No module. Okay. Did you install it? You might have to install it. Can you close this again?
Can you?
Yeah. So
Okay.
now you see where it says pip install pandas. Just remove
Install?
the. Yeah, you have to install it. Can you remove the pip install? Not remove it. The hashtag before it, so they would run.
Oh, remove the hashtag.
No, the first row.
Wait, is it the one on, are you talking about the PIP install pandas hashtag?
The hashtag before pip install pandas. On the first row. Can you
Okay. Pip
remove
install.
the
Hashtag. Remove it.
Yeah, remove it
Okay.
and run it now.
Okay. Let me.
I don't know what the error is going to be. Invalid syntax.
Okay.
Yeah.
So
that
that's
one.
Try putting a
Problem?
percentage mark or something.
Huh?
A percentage or an exclamation point?
Yeah, put an exclamation mark before the pip. Try that.
Before. Okay.
Yeah, I think so.
I might be
it's
wrong,
different
but
if you run it.
No,
Okay.
it's in
So
that.
let me see if we can find the right syntax, because
Okay.
it seems like an easy error to fix. Just 1 second. Let me see.
oh man, oh right, it's right here.
Um, Are you having, I mean, you have Python installed, right? On your computer?
Who are you asking?
Oh, I'm asking Shaifu.
Yeah, I'm not sure. Do I need to install it separately or?
Yeah, it might be because I'm not sure if this is a Python file. I mean, it looks like it, but
Yeah, it's Python, yeah.
you could use it on, if you wanted to just use it for this, you can just use Google Colab. You don't have to install anything. But if you want to use your shell, it's called Python shell, then you would have to install all of the packages.
Oh,
Let me
okay.
see
I
to
got it.
install. But it might be easier for now just to use Google Colab. Because yeah, I'm not 100% sure. I'm never really working with the regular like terminal.
Okay,
So
okay.
yeah. Sorry about that.
It's all right, no problem.
Cool. Is there any other questions?
No,
Awesome. So I hope to see you all next time. I'll still stay on. So, but you feel free to leave anytime. Next week we will plot our final results. And then yeah, and then everyone who attended all 3 workshops again will be put into a raffle. To be able to win a $50 gift card. We will have 3 winners. So the chances are not that bad. You're only competing against around maybe 60 people. So the chances are good that you will win. Thanks again for coming.
Thank you.
Thank you.
Yeah, on line 20 of the return analysis, I
Mhm.
noticed you wrote the FFIF fill twice.
Where?
Uh,
Um,
in line 20 of the return analysis.